Hello students. Today we will start a new chapter. This chapter is named as P block elements. In the last class itself, we have finished the S block elements. So today we will start a new chapter that is called P block elements. This lecture is presented by me, Pranit Ghatak, your chemistry teacher. So let's begin. Here in this slide, you can all see that in the periodic table itself, this whole part is being called as P block elements. In the last class, we have seen that in the S block element, this is called the S block element, and this is called the P block element. Okay, this is called the P block element, and in the middle, this part is being called as D block element. Okay, so right now, what we will dealing with? We will deal with this part. Okay, this is called the P block elements. Okay, these are mainly non-metals, but many metals or metal wires are there as well. Mainly non-metals almost, but some metals and metal wires are also there in the P block elements. So P block starts from group number 13 to group number 18. Group number 13 to 18. Okay. But in our syllabus, that is in our class 11 syllabus, we have only two groups in our syllabus, that is 13 and 14. So from 15 to 18 we will discuss it in the next class, that is in the class 12. Okay. So let's begin with the P block elements. Basically, what happened in the P block element, what are the characteristics we're going to discuss today. This will be an introduction to the P block elements as well as some physical properties of P block elements. Okay, so let's begin. In the P block elements, they are also belong to the group number 13 to 18, what I have already been said. And in our syllabus, in class 11 syllabus, we have only 13 and group number 13 and group number 14. Okay, and the general electronic configuration of the atoms are of this block are NS to NP1. Okay, so it depends on the group. Okay, in the case of group number 13, what I can give you a small idea about how can you just by using the group you can easily determine the electronic configuration. Okay, suppose the group number is 13. Okay, group number is 13. So what is the last digit? What is the last digit? The last digit is 3, right? So the number of valence electron will be 3. And as you know, in the P block elements, group number 13 exists in the P block. Okay, so in the P block we have the electronic configuration of NS and NP, and so the number of valence electron is only 3. Okay, and we know that S orbital can hold up to 2 electrons. So 2 electrons will be on the S orbital, and we have 3 minus 2, we have only 1 electron left, only 1 valence electron left. So what will be this one electron will be occupied in the P orbital. So the electronic configuration of group 13 elements will be NS to NP1. So let me repeat with another example, like if we take group number 15. So last digit is 5. Look for the last digit. So last digit is 5 in the 15 number. So the number of valence electron will be number of valence electron will be 5, right? And as you know, group number 15 is also be a part of P block element. So the electronic configuration will be NS and NP. First of all, fill the S orbital. That we know the S orbital can only fill up to 2 electrons, and we have 5 electrons. So 2 electrons will be occupied in the S block orbital, that is NS orbital, and 5 minus 2, that makes 3. So 3 electrons are still have to occupy. So this 3 electron will be occupied in the NP orbital. So the electronic configuration will be NS to NP3 in the case of group 15. Okay, so I will take another example so that you get very clear idea on this trick. This is a trick. This is not a very much consolidated concept, but this is a trick. I have used this trick for many a times to just determine the configuration, mainly the electronic configuration of each and every group in the periodic table. Okay, I have done this for the group D block elements as well. So in the next class, in the class 11, class 12, where the D block elements are also there, I'll show you the tick of the D block elements of electronic configurations. Okay, so let's just start with the group number 17. Okay, so what is group number 17? Halogens. Okay, so last digit, as you see, 7. So the number of valence electron will be 7, right? So the electron configuration ns and np. So as you know, 2 electrons will be occupied in the ns orbital, and 7 minus 2, that means 5. So these 5 electrons will be occupied by np orbital. So the electron configuration will be ns2 np5. So this is the way by which you can easily do the electronic configuration, that is the valence shell electronic configuration of any p orbitals. Okay, so please remember this trick. You will not find this trick in any book or any other lecture video itself. Okay, so please take a note on that as well. Okay, so as we have two groups, that is group number 13 and group number 14, today we will deal with the group number 13. Okay, in the case of group number 13, the elements are boron, aluminum, gallium, indium and thallium. Okay, these are the elements down the group. Okay, group number 13 contains mainly metalloid, boron and 4 metals, that is all 3 valencies. All have 3 valencies electrons. Okay, valence electrons. Okay, in the case of group number 3, only boron, okay, is a metalloid, and rest of all is metals. Okay, in the group number 13. And as I told you that group number 13 means 13, the last digit is 3, so the number of valence electron will be 3. So all of the 3 valence electron. Okay, so this proves I am right. I am done a good trick. Okay, and also, so in the case of aluminum is the most abundant. This is some basic knowledge about the group 13 elements. So aluminum is the most abundant metal in the earth crust. It is found in the mineral called bauxite. Okay, and you have know what is the formula of bauxite. Okay, is the ore of aluminum's ore is bauxite. Okay, most of our laboratory glassware contains boron, which helps prevent it from scattering when it's heated. Okay, this is the concept. Okay, this is not a concept, this is only a knowledge. Okay, so please take this knowledge and embrace it. Okay, so let's move to the next point, that is the physical properties. As I have already discussed the introduction to the p blocks, I have discussed it over here, and just we will start discuss about the physical properties of p block elements, mainly group 13. Okay, group 13 elements. Okay, so when we talk about the physical properties, we need to know the outer overlook of the elements as self. Okay, and their boiling and melting point as well. Okay. So boron is very hard, black color. This is black color. This is a concept of outer overlooking. Okay, and high melting point due to very strong crystalline structure or crystalline lattice, non-metallic solid. Okay, so this is being given a idea about the what is boron. Boron is a hard colored, high melting point, high melting and non-metallic solid. Others are soft metals with low melting points and high electric conductivity. As the others are metals, so they will be highly they will be acting as a conductor and they will have a high electrical conductivity. Density of the elements increases down the group from boron to thallium. And gallium is a useful material for measuring high temperature as its low melting point and very high boiling point. So please remember this point as well. Gallium is useful material for measuring high temperatures as it has low melting point but high boiling point. Okay, so it is we use it in the measuring the high temperatures. Okay, and the last part is atomic radius. Okay, in the case of atomic radius, it generally increases down the loop. That is, when we go from top to bottom, what happens? Radius increases, right? But in the case of aluminum to gallium, the radius decreases. The radius, what happens? Decreases. Okay, because in the case of gallium, due to poor shielding of intervening d orbitals, gallium radius gets decreased. Okay, in that reason, because of the shielding effect or skinning effect. What is skinning effect? Basically, what happens? The d orbitals and f orbitals cannot shield the nucleus properly, so that is why the the end orbitals, that is for the other orbitals, not get shielded properly, so that is why they will be attracted towards the nucleus, and as they are attracted towards the nucleus, so the distance between these orbitals and the nucleus will get reduced, so totally the overall radius will get reduced. Okay, so I can give you a small idea about the skinning effect. Suppose this is the nucleus, and these are the orbitals. Okay, suppose this is the d orbital and f orbital, and this is the p orbital. Okay, what happens if the d and f orbitals cannot shield properly? Okay, if they shield properly, then the electronic attraction force of nucleus will be in this p orbital will be less. Okay, in this p orbital, the electronic attraction force of the nucleus will be less. But if the d and f block, what happens in the d and f block doesn't shield properly, so that is why what happens if suppose they cannot shield properly. What happens in the case of d and f orbital cannot shield properly, so what happens? The nucleus charge. Okay, so I have removed the d and f orbital because they cannot shield it properly. So what happens? The nucleus charge of the nucleus, and the nucleus charge due to nucleus attraction force to the p orbitals will be increased because there is no shielding from d and f block. So what happens, as the attraction force is so huge, so high, because the nucleus is positive charge and in p orbitals contain electrons that are negatively charged, so they will attract each other. And what happens due to this attraction force, due to this high attraction force, what happens? The radius will get closer because the p orbitals was here, but right now due to the attraction force it will move closer, and by moving closer it will go to this point. In the first day, when if the d and f orbital were shielded, it will be there, but when due to the poor shielding of d and f orbital, what happens? The attraction force increases, and as the attraction force increases, the p orbitals or any other orbital that are behind from the d and f orbitals, they will come closer to the nucleus, and as they come closer to the nucleus, the radius will get decreases. The radius was firstly here, that is r1, and the r2. So you can see that r1 is far more greater than r2. So whenever the shielding occurs, what happens? The radius of the molecules decreases. Okay, as the radius decreases, so the size of the volume also decreases. Okay, so I hope you have understood the concept of shielding effect or skinning effect. Okay, so I have explained it properly. Okay, so in this class we have discussed about the introduction to the p block elements and also the physical properties of p block elements as well. Okay, so in the next class we will start with the chemical properties of p block elements. Okay, so that's it for now. I hope you have understood this part very well. If you have any kind of doubt regarding today's topic, please ask me in the comment section below. Okay, thank you very much.